we need to calculate the shear force. So first we need to take the member AC. Sorry, it's not B, it is member AC. So if you take AC in calculation of the span bending moment and shear force, we will consider the support as consider the support as simply supported. But in shear force we will consider the moment also. What is the moment acting at that point? So what we are going to consider this member AC. So I have taken AC and I have considered as simply supported, but I have provided the moment acting on it, that is the final end moments. So if you see the final end moment, the value is 5 WL square divided by 48. You will have a question, sir, we have calculated the MAC value as minus 5 by 48 WL square. So here you haven't mentioned minus, because that minus sign represents the rotation or the moment which is acting is in anti-clockwise direction. So I have drawn the anti-clockwise direction, so I have omitted the minus. And if you see here, the moment MCA is WL square by 24, it is in clockwise direction. So I have mentioned it in clockwise direction because we know the sign convention. If the value is negative, then it is in anti-clockwise direction. If value is positive, then it is in clockwise direction in case of moment. So I have calculated I have drawn the diagram. Next I am going to take the moment about C. So RA into L minus WL square by 12 is nothing but the load acting on the structure. The total load is WL and it is acting at a distance of L by 2 from the support. So WL square by 12 minus 5 WL square divided by 48, because if you see here it is in anti-clockwise direction, so I have included the minus. So if you see here it will get the minus which we have calculated. So in drawing we don't need to mention the sign. Instead of sign we need to mention the direction of rotation. So next WL square by 24 equal to 0. So if you simplify that, RA equal to 9 by 16 WL. So this is the reaction at A. Next we need to calculate the reaction at C. So if you substitute the condition RA plus RC equal to WL, that is the reaction at A and reaction at B, C will be equal to the total load. So total load is nothing but WL. So if you substitute in this equation, we are getting RC equal to 7 by 16 WL. Next we need to take the member CB. Since member CB does not have any load, we are going to assume that if one load is, if one reaction is acting in the upward direction, then the other reaction should act in the downward direction to complement or to counteract each other. So I am taking the C support as C reaction as acting in upward direction and B reaction as acting in downward direction. So we know that the moment is WL square by 24 at C in anti-clockwise direction and WL square divided by 48. This is also in anti-clockwise direction. So I have mentioned the direction. So instead of sign. So we are going to take moment about B, RC into L minus WL square by 24 minus WL square divided by 48 equal to 0. So if you simplify that, RC equal to WL by 16. So we have already assumed that the RC value is in upward direction. So we are getting in positive. So which we have assumed is correct. So we know that the in sign convention for force, if it is in upward direction then it is positive. If it is in downward direction then it is negative. So RB value is minus this because we have assumed it is in downward direction. So we have calculated the reaction at A, reaction at C and reaction at B. Next we need to draw the bending moment diagram and shear force diagram. We have calculated the final end moments and we have calculated the shear force. Next what we need to do, we need to draw the shear force diagram and bending moment diagram. So I have taken all the values which we have calculated, that is the moment at AC is minus 5 by 48 WL square and CA equal to WL square by 24, MCB equal to minus WL square by 24 and MBC equal to minus WL square divided by 48, and I have written the reactions RA, that is mean member AC, RA equal to 9 WL by 16, RC equal to 7 WL by 16, in member CB, that is RC equal to WL by 16, RB equal to minus WL by 16. So while drawing the shear force and bending moment diagram, always try to draw the given problem, that is given beam at the top, then draw the by extending it. So if you see here, I extended from A, I extended from B and extended from C. So first of all draw like that. and then first draw the given beam, then draw the bending moment diagram, shear force diagram. First we are going to draw the bending moment diagram. So if you see here, they have mentioned 5 by 48 WL square. So the value will be, okay, let us assume that it is the value will be at like at this point. So this is nothing but 5 by 48 WL square. Next value is WL square divided by 24. So let us assume it is like this at this point, WL square divided by 24. Next, if you see, it is minus. If we have assumed it as positive, so positive means in top, negative means at the bottom. So here if you see the value of MBC value will be here. Because if you see here, what we have assumed, MAC we have assumed in anti-clockwise direction, so it is in anti-clockwise direction. So if the what we assumed is correct, then we will mark it in the top, that is at the upward direction. If it is in the opposite sign, then it will be in the downward direction. Here if you see, the value is WL square divided by 48. So next what we need to do, we need to join all this. So this is due to the fixed end moments, that is final end moments. So this is the final end moment drawing for the given beam. Next what we need to do, we need to consider this load. So we know that if it is load is whatever the load, we need to consider as a simply supported, and we need to calculate the bending moment. So since it is a simply considered as a simply supported beam, section A is simply supported with an UDL, that is, it will be like this. So what is the formula to calculate the value? W per meter, and the length is L. So the formula to calculate the bending moment is, we know that WL square divided by 8. So we are going to mark it here. So it will be in the form of parabolic shape. So the value is WL square divided by 8. So here there is no load, so we won't get any bending moment due to span. That is span load. So here if you see this region, this is the negative bending moment. Here also we will have the negative bending moment, and this is the positive bending moment. So this is the actual bending moment. So this is the shaded portion is nothing but the actual bending moment of the beam. So we have drawn the bending moment. Next we need to draw the shear force diagram. So if you see the shear force diagram, they have mentioned 9 WL by 16. So it is positive. So positive is always in upward direction. So I have marked it as 9 WL by 16. And at RC also they have mentioned it as positive. But we can't have rise like this, because if we have a UL load, we know that the value will be, the shear force diagram will be a intersect, that is the cross like this. So we are going to mark the point here, that is 7 WL divided by 16. So this will also move in upward direction. If you take this point, this will is also in upward direction like this. So we need to draw like this. Next, if you see here, WL by 16. So I am going to mark the value here. It is nothing but WL by 16. So this is also going in upward direction since it is positive. So at B, if you take, it will be in downward direction, that is WL by 16. So this shaded portion is nothing but our shear force diagram. So this is nothing but our bending moment diagram, and this is nothing but our shear force diagram. So we have completed the problem, but we have completed the, we have solved the problem. Because in problem they asked us to draw the shear force diagram and bending moment diagram, we have drawn the both. So in this way you need to solve the problem. So next I am going to give you a tutorial problem, and you have to submit it by tomorrow.
This is the tutorial problem which you need to solve. So if you have any doubt, we will discuss those doubts on tomorrow's class. Just go through this problem and come prepared for tomorrow's class. Tomorrow we are going to have a live session.